Okay, we're beginning with the plug. "76 watts powering this this charger. This is a 42 volt, 2 amp, if I recall correctly. Yeah, 2 amp, 42 volt, 2 amp lithium battery charger for scooters. This is where I'm accessing the power. The inside is positive and the outside is negative, as demonstrated here in this diagram. Positive in the center, negative on the outside. That's what that shows. So we're connected that way here. Okay, this plug is powered into plugging this 74 watts. Okay. Positive wire is going. Let's follow it. The positive wire is going to this motor. The other side of the motor, this is a brushed motor with a positive and a negative, right? So on one side, the positive goes into the positive of the motor. The negative of the motor has the same wire, the same positive wire, now going to this. Now this goes, where does this go? Looks like it's going to this battery. Yeah, it's going to this battery. The plus on the battery. Okay, so the positive wire from this charger goes to the motor and then comes out and goes to the plus on the battery, and then the minus on the battery will continue in the same circuit in series, it's called. Let's see where the minus goes. The minus goes to this red wire and goes to the plus on this battery. So that's series, right? That's in series. Okay, now where does the negative go? If I recall correctly, the negative goes straight to this battery, because this is the main battery I want to charge. See how high the voltage is? 15.83 volts. That's a 12 volt battery. Okay, 12 volt car battery that was no good. And we're bringing it back to life. I'm thinking of it as, I guess you could call it time travel or reversing aging. It's changing the energy, right? Because fundamentally there's no time. So if there's no time, then what are we changing? We're changing the energy. We're reversing the energy or the cycle. I'm not sure how to say it. I'm still learning about how to think about this. But this is just one idea that I'm thinking about. What we do know is the battery comes back to life. That's what we know. I'm calling it that, but being usable again, okay? Okay, so negative from here goes, let's follow it. It goes directly to, yes, goes to this battery negative. Okay, now over here what I did, I think I connected this battery in parallel, so let's see, let's follow the wire. This negative goes to this negative, and this positive goes to this positive. So I just said, well, these batteries are both low on voltage, they're both about 7 volts. Let me connect these two in parallel and see what happens. That would make it like one larger capacity battery at the same voltage, right? And look what we're up to. We're up to 11.21 volts. Now if I disconnected the batteries from the circuit and put them there, and put something else in place of there, right? But put these batteries there, I think the voltage would increase very, very fast, because that's what it does. The first day I plugged this in, the voltage had significantly increased from what it previously was. So the battery was what I'll call rejuvenating quite quickly. Okay, so now we know what we did here, right? We know what we did here with this motor. And this motor is just turning this motor to put a load on this motor, which allows more amps, more power to go into the battery. That's one way of thinking about it. If you have your own thoughts and ideas, please make a video and share your thoughts and theories about battery rejuvenation with the Tesla one-wire experimentation. And that's just one way of explaining this, and I'm not sure that everybody would agree on that. But what I do know is this process permits batteries to work again. What do we call it? I don't know. I'm going to call it an experiment. So this motor, we know what we did here. This is basically a positive wire going through this motor and making a turn, right? So here on one side, when we do that, which in a way is like going in series with this motor, when we connect it this way, if you read with your meter, one side will read positive and one side will read negative. So what I did was, in parallel, on the positives, I put all the red wires, all the positives to the positive of these motors. So all these motors are in parallel with this motor. The negative side, I connected to all the negative wires. So let's follow that. So this wire here goes to this, and you can see that goes to the negative there, and goes to the negative there. And then our positive wire, positive side, is the red side. That goes here to the positive, goes positive there, and goes to the positive there. Now I can keep running more motors in parallel all the way out. What I noticed was that the more motors I put, is the quicker this voltage increased. What I watched was temperature of battery. Battery has remained at ambient temperature. It has not increased in temperature, which is a good sign. When you're doing new experiments like this, it's good to keep a close eye on voltage and temperature. Temperature is very important to watch for batteries, and not to leave the experiment while you go get to the market or go run errands. It's very important. You can stop the experiment then. These experiments must be monitored at all times, so just always watch them, especially when it's a new experiment, okay? Okay, everyone, have a great day. Bye-bye.